Welcome back, guys, to another day of the TryHackMe ad event of Cyber 2025, and today is day number 5, dealing with IDOR, Santa's Little IDOR. So let's go into this room. So it says we're going to learn about IDOR while helping pen test the TryPresentMe website. It says that this is going to be a medium difficulty lab and should take about 45 minutes. Okay, the story for day 5. The elves of Wareville are on high alert since McSkitty went missing. Recently, the support team has been receiving many calls from parents who cannot activate vouchers on the TryPresentMe website. They also mentioned they are receiving many targeted phishing emails containing information that is not public. The support team is weary and has enlisted the help of the TBFC staff. When looking into this particular case, they discovered a suspiciously named account named Sir Carrotbane, which has many vouchers assigned to it. For now, they have deleted the account and retrieved the vouchers, but something is going on. Can we help the TBFC staff investigate the TryPresentMe website and fix the vulnerabilities? Alright, so the learning objectives, we're going to understand the concepts of authentication and authorization. We are going to learn how to spot potential opportunities for insecure direct object references, IDORs. We're going to exploit IDOR to perform horizontal privilege escalation, and we're going to learn how to turn IDOR into SDOR, the Secure Direct Object Reference. Now for this, we will be having our attack VM started today, and we're going to have a regular virtual machine started as well. Of course, these are going to take 2 minutes to start once we start the machines up. So I'm going to start my machines, and we'll be back when they are finished starting. Alright, so we can see that my machine has started, my attack box. So we are going to answer the question below that says, my target machine and attack box have started and I'm ready to learn about IDOR. Alright, so they're both on. Let's just note the IP addresses up here. Right, so the attack box, which is what we're currently in, is 10.67.67.62. And the IP address for my environment for my target machine is 10.67.172.177. So let's make sure we go and note these down. All right, so let's check this off. Fantastic. All right, so now we're going to learn about IDOR on the shelf. So it says, have you ever seen a link that looks like this? And this link says https://awesome.website.thm/track package package ID, and it says 1001 as the package ID. So it says, when you saw a link like this, have you ever wondered what would happen if you simply changed the packet ID to 11 or 12? In its simplest form, this can be a potential case for IDOR. IDOR is the Insecure Direct Object Reference, and it is a type of access control vulnerability. Web applications often use references to determine what data to return when you make a request. However, if a web server doesn't perform checks to ensure you are allowed to view the data before sending it, it can lead to serious sensitive information disclosure. A good question to always ask is, why does this happen so often? Well, first we need to understand the references and web development a bit more to answer this. If we scroll down, we can see a table storing the package numbers from the link example that they provided. So we can see we have package ID of 1001, 1002, 1003, 1004, 1005. And these each correlate to a person, an address, and the status, either being delivered, in transit, out for delivery, pending, or returned. Now it says, if the user wants to know the status of their package and makes a web request, the simplest method is to allow the user to simply supply their package ID. We recover data from the database using the simple SQL query of select person, their address, and their status from packages, where package ID is the value that they put in. However, since package ID is a sequential number, it becomes pretty obvious to guess the package IDs of other customers, and since the web application isn't verifying that the person making the request is the same person as who owns the package, an IDOR vulnerability appears, allowing attackers to recover the details for packages belonging to other users. Even worse is when a feature like this doesn't require users to authenticate. Then there would be no way to even tell who is making the request. To dive a bit deeper, we need to understand authentication, authorization, and privilege escalation. It does say a note here from one of the co-authors of the task saying that they're not a fan of the vulnerability named IDOR. They prefer the name authorization bypass. So let's talk about identity defines our reach. So to understand the root cause of IDOR, it is important to understand the basic principles of authentication and authorization. Of course, we know that authentication is basically verifying who you are, right? This is done by usually supplying a username and a password. Authorization basically just verifies your permissions, right? It allows you to, for example, access a website or allows you to make a payment using a specific account. You may think that authentication only happens once you supply your username and password, but that is actually not the case, right? After you provide your credentials, you usually receive a cookie or a token. This is called session information. Every subsequent request you make to the application includes the session information, which is verified by the application. This initial verification process is still authentication and happens for each request. This is why websites will often redirect you back to the login page. It means that your session information has expired and you need to re-authenticate your credentials to receive new session information. Authorization cannot happen before authentication, right? They need to prove who you are first before they give you permissions. If your IDOR doesn't require you to authenticate, being a login or provide session information, such as our packing tracking example, we will have to fix authentication first before we can fix the authorization issue of making sure that users can only get information about the packages that they own. All right, so let's talk a little bit about privilege escalation types. So we have vertical privilege escalation and horizontal privilege escalation. Now, vertical privilege escalation is basically when you gain access to more features. For example, you may be a regular normal user on an application, but you can perform actions that should be restricted for administrators. Horizontal privilege escalation just means that you are getting features that you're authorized for, but you're also gaining access to data that you should not be getting access to. For example, you should only be able to see your accounts, not someone else's accounts. IDOR is usually a horizontal privilege escalation. You are allowed to make use of the track package functionality, but you should be restricted to only performing that for your own packages, not for other people's packages. All right, so now we're going to look at how to exploit IDOR practically. So it says, let's start with the simplest example, IDOR on the web application. Let's authenticate to the application using the details below. All right, so we get the username, the password, and the IP website. So we're going to go to the website on Firefox. All right, so we're going to put that IP address in on Firefox being 19. Nope. All right, so we're going to put the IP address on the Firefox being 10.67.179.177. And it's going to ask us for a username and password. Now the username is Niles, Niels, and the password is going to be TryHackMe $2025. I'm going to press login. We're not going to save that password. All right. So once we authenticated our authentication, we put in our username and password. We should see the dashboard. It tells us that we should start using the developer tools on our browser to better understand what is happening in the background. It tells us we can right click on the web page and click inspect. So we're going to right click and we're going to go to inspect Q. And it's going to load on the bottom of the page for us. And then it says to click on the network tab as shown in this picture. All right, so we're going to go right here to network. All right, so there's nothing in there. We're going to want to refresh the page and see what requests are being made. So let's refresh the page. All right, so we can see there was a few different requests that were being made, and we can see the status code for them as well as the method, the domain, the file, etc. So we're going to take a closer view at this one, the view underscore account information question mark user underscore ID equals 10. So we can click on this to see details about it. Now I'm just going to make this big over the web page so we can see everything at the same time. All right, so this shows us that we are the user underscore ID is equal to 10. Right? If we click this, it will expand the responses, right? So we can see our name, Niles, the email, the first name, last name, ID, address, etc. All right, so this is the website that we are on uses user underscore ID as a reference for getting our information. So what happens if we change that? So we can change that by going to storage up here. Under local storage, we're going to go to the IP address that we're on. And we're just going to change this 10 under authentication or auth underscore user from 10 to anything else. Let's go for 11. Press enter. Right, this is an example of an IDOR, right? By simply changing our user underscore ID to something else means that we could possibly see other people's data. Some IDORs might be more hidden. Just because you don't see a direct number doesn't mean it doesn't exist. All right, so we're going to go back here and change this back to 10 for the following exercise steps. Alternatively, changing that, we could also just log out and log back in, right? All right, so let's close out this inspection window. So it says in disguise, obvious references. It says sometimes IDOR may not be as simple as a number. In certain cases, encoding may be used. On the loaded profile, which we're on here, we can click the eye icon next to the first child as seen in the instructions. And this will show information about them. Now, if we go back to that inspection window, and look at network, and let's just actually refresh the page and click on the Bilbo eye, we can see with the request being made, right? And we're going to want to look at this bottom request here, the mg equal file. Specifically at the header is where we're going to look. My example does not show a header like theirs does, but you can also just scroll up and you can see child ID 2, which they say that the number for this user is number 2. And we could still perform an IDOR using this request, but we would want to have a base 64 encode the first number, just like they have it on here. Base 64 encoded version of the number 2 is mg equal. Right? Let's close that and let's lower this. All right, so now it says in digest objects remain. So encoding isn't the only thing that can be used to hide potential IDOR vulnerabilities. Sometimes the vulnerabilities may look like a hash, such as an MD5 or an SHA1. If you want to see what that looks like, you can take a look at the request that happened when we click the edit icon on the child. All right, so if we click on the edit icon, edit child, and we actually look at the network field in here, we can see this bottom one, right? In this, we can see that it's getting the MD5 value. Might be a little hard for you guys to see, but it is getting the MDI value with the get command. Now, while the string may look random, as we can see here, it does show us the MD5 value hash of it. We understand what this value is, right? And this can be used again to perform an IDOR attack simply by replicating the hash function. Using something like hash identifier, we can help quickly understand what hashing algorithm is being used and can often tell what data was hashed. All right, the next one is deterministic. All right, so it says sometimes we may have to dig quite deep for IDOR. Sometimes IDOR is not as clear. Sometimes the IDOR stems from the actual algorithm being used. In the last case, let's take a look at our vouchers. While the values may look random, we may need to investigate what algorithm was used to generate them. Their format looks like the UUID, so let's use the website, such as the UUID decoder, to understand the UUID format that was used. So we can copy one of the vouchers to the website for decoding, and we should see something like what they have on the instructions. All right, so let's do that. So let's open up the UUID decoder website. I don't know what website we're going to. UUID tools. So this first one. All right, now let's enter the UUID. All right, so we can find this UUID in the investigate right at the end, right here. This at the end of this child link is the whole UUID. So we're just gonna right click and copy that value. I'm going to paste it into the UUID decoder. And it says that UUIDs are in this format, so we got to make sure we do it in that format. So it's 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then the dash. Then there's a 4, 4, and 4. So 1, 2, 3, 4. Then a dash. 1, 2, 3, 4, then a dash, and I am not counting all this, but that should be correct. So let's see what happens when we hit decode UUID. Oh, I forgot the last 4. 1, 2, 3, 4. All right. So when we have this UUID properly formatted and we decode it, we can see what the standard string format is, what the single integer value is, what the version is, the variant, and the contents. While these look completely random, we can see the UUID for this child that we already had open was 2, but they're showing us a version 1 was used on another account. The issue with UUID version 1 versus 2 is that if we know the exact date when the code was generated, we can recover the UUID. For example, suppose we knew the elves generated vouchers between a certain time, 10 p.m. and 11 p.m. In this case, we can create UUIDs for the entire time period, 3,600 UUIDs, since we have 60 minutes and 60 seconds in a minute, which we could use in a brute force attack to aim to recover a valid voucher and get more gifts. Now that we have seen various IDORs that can be found, let's discuss how to fix them and avoid them. Right, so improve design, obliterate risk. Now that we have learned about IDOR, let's discuss how to fix it. The best way to stop IDOR is to make sure that the server checks who is asking for data every time. It's not just enough to hide or change the ID number. The system must confirm the login user is authorized to see or change that information. Don't rely on any tricks like base64 or hashing the IDs. Those, like we just showed, can still be guessed or decoded. Instead, you want to keep the real permission checks on the server. Whenever a request comes in, check, does this user own or have permission to view this item? You also want to use random or hard to guess IDs for public links, but remember that random IDs alone don't make your app safe, right? You don't want them to be in sequential order. Always test your app by trying to open up another user's data and making sure it's blocked. Finally, record and monitor failed access attempts. They can be early signs of someone trying to exploit an IDOR. Alright, so it asks us some questions here. Alright, I apologize guys, my recording software messed up. But for the first question, it was what does IDOR stand for? And that was the Insecure Direct Object Reference. Right? The other question was what type of privilege escalation are most IDOR cases? They're horizontal, not vertical privilege escalation. And then what we did to find the exploiting of the IDOR found in the view accounts parameter to get the parent who has 10 children, we basically went into the network for Niles. We went to the view underscore account information where we could see that he was set to 10. We went to storage, to the local storage, and went to the only storage there, the http :10.67.172.177. And under auth underscore user, we basically incremented up from 10 to 15, right? Because he had 4 or 5 children. This parent has 10 children, right? So we just incremented by 1 just to get to find the number that has 10 children, and we can see that by scrolling down and counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he has 10 children, and we can see the email, the ID number, and the address. All right, so that's how we got that answer. Now there are 2 bonus questions that you can do. And the first one says, if you want to dive deeper, we can use the base 64 or the MD5 child endpoint and try to find the ID underscore number of a child born on 2019-04-17. It says to make this faster, we can consider using a tool like Burp Intruder. If we want to check your answer, we can click on the hint icon over here. And the other one was if you want to go further and you want to use it does say if you want to go further, you can use the /parent/voucher/claim endpoint and find the voucher that is valid on 20 November 2025. It says insider information tells you that voucher was generated exactly on the minute, somewhere between 8 p.m. and 12 p.m. UTC that day. It asks what the voucher code is, and of course you can check your answer by clicking on the little hint icon. And of course, if you enjoyed this room, it says that you should check out the IDOR room. But we're not going to do that. We're just going to check that off. There we go. It took a minute to get there, but it does say that we have completed this room, being the IDOR-Santa's little IDOR. All right, this was a medium difficulty room. So good job on that, guys, that you did that. That was day number 5 of the TryHackMe. All right, join me back here tomorrow for day number 6. All right, I'll see you in the next video. Don't forget to like, subscribe, and hit that notification bell so you never miss an update. Thank you for watching, and I will see you in the next video.